Hello friends, so today's topic is shear force diagram and bending moment diagram. So in this we will cover types of beam, types of support, cross section of beam and types of load. What is shear force diagram and bending moment diagram? So simply shear force and bending moment diagrams are analytical tools used in determining the value of shear force and bending moment at a given point of a structural element such as a beam. These diagrams can be used to easily determine the type, size, and material of a member in structure so that a given set of loads can be supported without structural failure. So this is the mainly used of the shear force diagram and bending moment diagram. A beam is a structural member subjected to transverse load only. So in this first we will cover types of beam. So as you can see, this is a cantilever beam. In this cantilever beam, one end is free and the another end having a fixed support. So this type of beam is known as cantilever beam. Okay. Second is end supported cantilever, means this is a cantilever beam. At A end the support is fixed support, but at B this is just a simple support. So this type of beam is known as end supported cantilever beam. Next, this is rigidly fixed or built in. If a beam have both the end with the fixed support, and this beam is known as rigidly fixed or built in. Next, this is simple support. If a beam having a simple support at both the ends, then this is simply supported. And in overhanging, you can see at A this is a simple support, at B point this is a simple support, but at C this is extended beam and there is no support. So this is just a hanging. So we will say this is a overhanging beam. Next, this is continuous where number of supports are there, like A having support, B having support, and C is also having support, and maybe continuous. So these are the types of beams, types of supports. So as you can see, this is the first is simple support, roller support, pin support, and fixed or built-in. So what are these supports and what are the reactions on that supports? We will discuss now. And first, you can see this is the diagram where simply this is act like a beam and this is support to that beam. So this is a case of simple support like this, you can see. And this is a second one, that is a roller support. You can see these are the rollers, 1 2 3, and this is a structure. We can say this is a one type of beam, this is a whole structure and the supporting by this roller. And if you want to see, then this is a roller support. Next, this is a pin support where this is one type of beam and having the pin support, as you can see, and like this is a pin support. And next one, this is a fixed support, so totally built in, and this is a totally fixed on the wall, the structure, and this types of structure is known as fixed support. And so what are the reactions on that supports? Just look at this first. If there is a simple support, then only and only the supports will supports in vertical direction only. As you can see, this is RAY, this is the support in vertical direction only. Okay, there is no support from horizontal, like that. So only vertical force can be supported by simple support. If I'm talking about the roller support, then the same, this will also support only vertical force, vertical load, but there is a little bit sliding allowed. As you can see, these are the rollers. So if in case it's required to slide the support, then the roller support can be used and a little bit limited sliding is allowed. Okay, next is pin or hinge support. In this you can see there are the reactions are two, and in this, as you can see, this is a vertical and this is axial, or we can say horizontal supports. So this what this pin support is having like the support from this vertical side also, and this will also support in this direction only, but there is no support in moment. It is allowed. So like fixed support, in this, as you can see, there are three reactions. One is vertical, one is axial, and one is moment. So all the reactions are there, three reactions are there So this is types of fixed support. One is pin support and one is roller support, and this is the load W. So what will happen? So first, this is two reactions, and here is only one reaction like this, as you can see. So now as the load W increase, so as you can see, this is a deflection and the roller is little bit slide toward lefts. Okay, and again, if again this is the deflected, then the roller is again slide towards left like this. So this is the combination where pin support and roller supports are used section of the beam, so that you can see there are maybe different types of cross section of the beam. So simply in this diagram you can see this is a T bar. So maybe this type of cross section you can use, but you just have to calculate the moment of inertia of the T shape. So that I should be required from this. First you have to find the centroid of this T section. After then from XX, okay, from XX you have to find out the moment of inertia IXX. That will be used in this bending equation. Then that will if you want to find out the bending stress on the beam, then you have to find out this IXX. So next is like a wide flange, as you can see, channel, L angle, I beam. This the difference between this wide flange and I beam is only this, the length of this is short. So this is I beam, and next is HSS, and this is hollow structural sections, HSS. So in this maybe we can take a like circular section. So next is types of load. So in this you can see there is a types of different types of load, like point load, point moment, uniformly distributed load means the intensity of the load is same at every point, and like a uniformly varying load means you can see the intensity is increasing in the same rate like this. And we can say trapezoidal means simply the UDL and UVL combination. If I'm making a line here, then this is UDL and this is UVL. Different types of force, and as you can see this is a simply supported beam and this is cantilever beam. So like if point load is act on the simple supported beam, then it will be act like this. On cantilever it will be act like this force. So simply what is shear force? So shear force at any cross section of a beam may be defined as the unbalanced vertical force to the right or left of the section. So bending moment at the cross section of a beam may be defined as algebraic sum of the moments of the forces to the right or left of the section. Talk about the sign convention. So as you can see, like just look at this. This is a beam. Okay, if you are taking any section like this, AA is the section towards the left of this section. If the force is upward, left of the section, if the force is upward, you have to take this is positive shear force. Same right to the section, if the force is downward like this, then you have to take positive, you have to take positive. Left of the section, left of the section, if the force is downward, then this is negative. And right of the section, if the force is upward, then this is negative. So if you want to remember, then you can say simply this is upward, so this is U, this is downward, this is D, this is downward, so this is D, and this is upward, so this is U. So you can say simply L, U, R, D, R, D, these are positive, or simply L, D, and R, U. Okay, these are negative. If you want to remember, then you can just remember like this. So just look at this. So these are the section XX, and the failure may be like this, might be like this. this one, this one. So in this, simply remember left upward force, right to the section, downward force, left to the section, downward force, right to the section, upward force. And you will see in like this. This is a clockwise, this is clockwise, this is counterclockwise, this is counterclockwise. Combination of these arrows are come in a clockwise, then this is a positive, and if the combination of arrows are in anti-clockwise, then this is a negative. You can remember like this also. And one method is also again like simple method. You just look at this. This is a vertical, this is section. If this is a clockwise, positive, like this is clockwise, then positive. If this is counterclockwise, then negative, counterclockwise, then negative. So these are the sign convention for shear force. Now we will talk about the sign convention for bending moment. This is a very simple sign convention for bending moment. Just look at the diagram. So what will be the shape of the after the bending? So like this. So bending may be like this. So yes. So this is the best method to remember. This is simply a sagging. This is hogging. But if you want to remember, then if this is a smiley, just make a smiley. If this is a sad mood, then this is a sad mood. So always smiling means positive bending moment, and if sad, then this is a negative bending moment. So just remember like this, and so completed. So now just for cantilever bending moment and shear force diagram, just follow the uh, just go through the second part.